and welcome to National Chemistry Week. My name is Hannah, and I'm a chemistry graduate student here at Purdue University. Today I want to talk to you about the science of glues and adhesives. Surely you have a bottle of this in your home. But have you ever thought about how this liquid glue can adhere together your art projects, but other things do not stick together? Why is it that glue doesn't stick to the sides of its own container? And how is it that animals like lizards can stick on walls? Stick around, and we'll learn this and so much more. Before we start, let's make sure that you have everything you need. If you live in the Lafayette area, you probably got one of our kits through your school. But if you're watching from somewhere else in the world, no worries. Most of the items that we're going to use today are common household items. This is what you'll need: 2 small cups, a piece of string with some tape attached to the end, a plastic spider, a small piece of paper, 6 craft or popsicle sticks, a piece of Velcro, both sides, 3 feet of string, a binder clip, about a tablespoon of flour, and a small glass of water. Now that you have all the materials, the first thing that we need to learn about the science of sticking is that sticking is all because of forces at play at very, very small scales. Everything you see around you is made up of small building blocks called atoms. We can think of atoms kind of like Legos. Atoms could come together to form molecules. And these molecules can interact with each other in a variety of different ways. If they interact with molecules of the same kind, this process is called cohesion. But if they interact with molecules of a different type, say yellow and black Legos, this process is called adhesion. Let's take a closer look at cohesion with our first experiment. Take your 2 cups, one with the tape and string attached to it, and the other one with a little bit of water in it. Pour the water into the cup that has the string attached, and place the string inside of the cup to make sure that the string is fully wet. Once the string is fully wet, pour the rest of the water into your second cup. Next, take the string from the first cup, the now empty cup, and put it into the cup with the water in it. Next, take your finger and hold the string taut or tight between the 2 cups. Lift the second cup up and tilt the first cup at an angle. This makes sure that the string is not touching the side of the first cup. And finally, pour the water from the second cup into the first cup. So what's happening here? Rather than the water just spill out of the cup, it's sticking to itself. This is cohesion in action. The yarn is wet, so there's already water there, and the water from the cup would rather stick to itself than fall off the side. Now let's look at adhesion in action. Grab a small piece of paper from your bag and draw a thin line with pencil. Next, take your piece of paper and dip it into a glass of water, but only up to the level where you drew the pencil line. Take the piece of paper out and watch as the water travels upwards beyond the pencil line that you drew. This is because water keeps on moving up the paper to interact with the paper surface. This is adhesion in action. You see this all the time. For example, if water is in a very thin and narrow glass container, it adheres to the walls of the container and makes the top look curved. This is adhesion in action. How cool is that? Now we've learned about cohesion and adhesion. But to make a glue, we need something that's really good at both. Let's think about this. Glue is the filling in a sandwich between two things we want to stick together. If our glue is only strongly cohesive, it won't stick to whatever we want to glue together. This means that neither of the sandwich faces will be coated with our glue. If the glue is only strongly adhesive, then it'll stick to things, but it won't be able to hold them together. So both of our sandwich faces will be coated in glue, but we still won't have a sandwich. If it is both strongly cohesive and strongly adhesive, our sandwich is successful. The glue sticks to each face of the sandwich, and because it sticks to itself, everything sticks together. We use water to learn about cohesion and adhesion. So do you think it would make a good glue? Let's give it a try. Take the piece of paper from earlier and completely submerge it in water. Next, stick it to a surface, like a wall or even your forehead. How did it work? Not very well, right? You can easily peel it off, or eventually it'll fall off on its own. When that happens, which one of the cases we just talked about do you think it's most like? Both the paper and the surface are wet. This is because water is really good at sticking to other things, which makes it strongly adhesive, but it is not very cohesive. Therefore, it's not a good glue. So far, we've learned that we need a glue that is both strongly adhesive and strongly cohesive. We've also learned that water is not a great glue. But can we make a better glue? Let's try it now. Take the cup of flour from your bag, or if you don't have a bag, about 1 tablespoon of flour, and add to that about 1 tablespoon of water. If you add too much water, your glue won't be very strong. So play around with the ratios until you get an appropriate glue. So add water to your flour and take one of your 6 craft or popsicle sticks and use it as a mixing tool. Now that we have our glue ready, take 2 more of your craft or popsicle sticks, and we're going to apply glue to about 2 inches of the popsicle stick, leaving the end free. I'll show you what I mean. Apply glue, about 2/3 of the way across, and leave one of them without glue. Now take your other craft or popsicle stick and place it on top. Now place it aside to dry. With the remaining 3 craft or popsicle sticks, we're going to make a star shape. First, apply a small bit of glue to the middle of one of your craft sticks. Then, take another stick and place it on top. And repeat for the last stick. And the end will be left with something like this. We'll let this dry for a minute, but in the meantime, how about we talk to one of our friends who works in a lab that actually works on developing new glues, specifically made to work underwater.
Hi, welcome to the Wolfer Lab, where we do chemistry that sticks.
Did you know there are animals that make their own glue? Yes, they are. Marine mussels are one of them. These animals live in the ocean, stick together in the rocks, so the waves will not wash them away. Here at Purdue University, in our lab, we study their sticky chemistry to understand how they produce their own glue. We also use them as an inspiration to make our own glue in a similar way like you just did today. Mussels are pretty strong, and here you can see the sticky strings mussels make and how strong they are. Can you see this mussel just hanging by itself with just 3 strings? Isn't that cool, right?
Hello everyone! We're going to show you how to measure how strong a glue is. This instrument we have here will pull apart 2 sticks and tell you the force required to make the glue fail. Today we're going to compare the flour glue you made at home against Elmer's glue and Gorilla Glue. Gorilla Glue is typically used for wood, and Elmer's glue is typically used for paper, like works you do at school with art, craft, and projects. They all have different sticky chemistry. So, are you ready to see which one is strong? Is it the Elmer's? Is it the Gorilla? Is it your flour glue? Can you take a guess? So we just ran our little experiment and we found out that actually Elmer's glue is the strongest one. Second by Gorilla Glue, and then your flour glue. The Elmer's glue is actually 50 times stronger than the flour glue. You can see here that the flour is still holding pretty good the wood. But if you want something pretty strong for wood, just use Elmer's glue. Because you can still, if I use my own hands, still require a lot of force to break that flour you're doing at home. This is how you do experiments in the lab to test how strong a glue is. And now we're going to pass you with Hannah so she can show you how to do your own testing at home. Thank you.
So you've seen how professionals test the strength of glue. How about we make our own shear test to test the strength of the glue that we made? Now that the glue is dried on your craft or popsicle stick, we can test the strength of the glue using a paper bag, a binder clip, the 2 craft or popsicle sticks glued together, and some pens or other household items. Using the binder clip, secure one end of the popsicle or craft sticks to the inside of your paper bag, like this. You'll hold on to the other end of the craft or popsicle stick. Then, slowly, one by one, place in the pens or other small household items to test the strength of your glue. star structure we made? Well, Halloween is coming up, so how about we make a spooky little craft while we go over some glue facts. Okay, now go ahead and tie your string at the center of the sticks and make a knot. Next, we're going to take the string and pass through the center of each one of these, like this. Next, we're going to loop around each one of the sticks once, and then move to the next. Be sure that we leave enough space to start creating a web. Have you ever wondered why glue doesn't stick to the inside of the bottle? You actually already have some experience with this. Earlier, when we made our glue, we added water. And while it was still wet, the glue wasn't very strong. Once it dried, it actually kept the craft sticks together. The white glue that you buy at the store also has water, but when the glue is inside of the bottle, there isn't enough air for the water to evaporate. But not all glues work like this. Some glues, like super glue, actually need water to harden. That is why super glue very quickly dries after it is opened. All the moisture from the air hardens it quickly. Spider webs are also stickier with some moisture. Speaking of spider webs, all our string webs need now is to attach the spider. Take the spider and hook it onto the string web. Like this. Have you ever wondered how spiders and other animals are able to climb up walls? Well, spiders have hair all over their legs, and each one of these hairs is covered in smaller hairs called setioles. Setioles form weak attraction forces with surfaces, but they have hundreds and thousands of contact points between the setioles and the surface. This allows the animals to climb up walls and hang from the ceiling, but those weak attraction forces aren't strong enough to actually hurt the animal when they get unstuck. Think of it like two books that are held together by overlapping pages. Sure, the attraction force between one set of pages isn't strong, but the attraction force between hundreds of pages overlapping is surprisingly strong. Take a look at a piece of Velcro. This is the same concept at play here. A lot of tiny structures that stick to other structures. This sort of thing applies to glue too. Glue can seep into nooks and crannies in materials to make more contact with surfaces and be even stronger. After you're done playing with it, you can use the Velcro to attach your string web wherever you want. Just peel back the paper on one side of the Velcro, stick it to the back of your string web, and then peel back the paper on the other side of the Velcro and attach it wherever you want. We hope that the next time you look at your string web, you'll remember that we learned that cohesion is the attractive force between like molecules. Adhesion is the attractive force between different types of molecules. Good glues are strongly adhesive and cohesive. We can test the strength of the glue using a shear test to determine how strong the glue is. Thank you for joining us in celebrating National Chemistry Week. Share your science with us using the hashtag NCW and hashtag ISPPlutonium, and tag us at ISPPlutonium on Facebook, Instagram, and Twitter. Have a good one, and keep on sticking with chemistry.